For this math, we need to differentiate this term. We can do it in two methods. At first, we can take, in one method, we can take d square y by dx square as the subject and move all of the other terms to the right and then differentiate it. And the other method, which I prefer, would be differentiating it directly. For the first term, which is y d square y by dx square, we need to differentiate it using the product rule. At first, we need to differentiate y, and we use the formula with this as the u and this as v, and the differentiation for this would be u dv by dx plus v du by dx, and we apply that for the first term, and then we differentiate normally. The implicit differentiation we have learned in P4. So this is the first line we get. We differentiate d square y by dx square, which is using the product rule, which would be y d cube y by dx cube. Then we differentiate y and keep this the same. The derivative of y is dy by dx times d square by dx square. For the second term, we differentiate normally, and then we use the chain rule basically, which would be 4 dy by dx, and then we differentiate this, which is inside dy by dx, whose derivative is d square y by dx square, and finally we have minus 2y, which differentiates to give us minus 2 dy by dx. Then we move everything except this term to the right, as we need to find d cube y by dx cube in terms of dy by dx, d square y by dx square, and y. We get this line. From here we can take dy by dx common for both terms and divide the right side with y. Divide both sides with y. This is what we get. 1 by y dy by dx minus 5 d square y by dx square plus 2. We can simplify this a bit and write it like this, and this would be the answer for part A. We need to apply Maclaurin and Taylor series to find the series solution of y. We are given that at x equals to 0, y equals to 2, and dy by dx equals to 1. At first, we plug in the values in the first equation that we have over here given and find d square y by dx square. So let's do that. We plug in the values of this is for dy by dx. Here's the equation: 2 dy by dx square, where dy by dx is 1 and y is 2, so minus 2, y is minus 2 times 2, minus 4. We make d square y by dx square the subject, and we get that it's 1. Now using this these three values of d square y by dx square, dy by dx, and y, we find out the value of d cube y by dx cube using the formula we have found out in part A. So we calculate that. We get this term over here, which equates to minus 3 by 2. And now we look at the Maclaurin and Taylor series formula that we are given with. As x equals to 0, we can apply the first formula here of f of x equals to f of 0 plus x f prime of 0 plus x squared by 2 factorial f double, the second derivative of y at 0. So we know those values. This is the formula we will be using, and we know the value of y at x equals to 0 is 2, and that of dy by dx is 1, and we calculated that d square y by dx square is 1 at x equals to 0, and finally d cube y by dx cube is minus 3 by 2. Now we plot in these values in this formula, and we get y equals to 2 plus x times 1, which is x, and then x squared by 2 factorial times 1, which is x squared by 2, and finally x cubed by 3 factorials times minus 3 by 2, which is minus x cubed by 4, and this is the series solution that we needed.